When we divide a polynomial by a monomial, each term on top should be individually divided by the term that is on the bottom. For instance, with the one that is here, one term on top divided by one term on bottom. Well, we can reorganize our division so that we take this a little piece at the time, just reducing this fraction. 10, if I divide by 2, gives me 5. And for the variable part, remember that our rule for dividing says keep the base and subtract the exponents when we're dividing things that have the same base. Our base of x in both things tells us let's just subtract the exponents. 5 minus 2 gives us 3 for the exponent. So for this one, just reducing this fraction, 10 divided by 2 gave me 5. X to the fifth divided by x squared gives me x cubed. And the entire quotient is just 5x cubed. If we have a little bit bigger one, like the binomial here being divided by 2x squared, we can rewrite this so that each term on the top is individually divided by the 2x squared. Each term on top individually being divided by the 2x squared allows us to have just fractions to reduce. Well, the front part is the same thing that we did on the previous problem, so you know it's going to be 5x cubed. On the back, if we have negative 4 divided by 2, that gives us negative 2 as a result. And x to the fourth divided by x squared, keep the base. 4 minus 2 leaves you 2 for the exponent. Notice that these things do not combine because in the original problem, the things in the numerator would not combine. Notice also that for each of these, the larger exponent was in the numerator, so the stuff that was left over was in the top part of a fraction. Let's look at a little bit bigger one, a trinomial being divided by one term. And again, we can separate this so that each thing on top is individually divided by each thing on the bottom. Each part, 10x to the fifth over 2x squared, minus 4x to the fourth over 2x squared, and 3x cubed over 2x squared. Well, the first two terms were the same as the last problem. It's only the part on back that's new this time. Notice that 3 cannot be divided by 2. So let's leave a 3 on the top and a 2 on the bottom. For the variables, the larger part is in top. So whatever's left is going to go on the top. And 3 minus 2, there's an understood 1 exponent that is here. Here are 4 terms on the top divided by just 1 on the bottom. And you guessed it, we're going to put each term on top individually over 2x squared. The only thing that's new is back here on the back, we've got 2x squared being divided by itself. Anytime you divide something by itself, the result is 1. It is necessary for us to have this 1 as part of it because the back 2x squared was being divided by itself. One more, this time 5 terms on the top. The only thing new is that we've got this plus 8 back here. Each thing on top individually over 2x squared, and we're going to reduce the fractions. The front 4 terms are the same as the previous problem. This one is the new one. If you take 8 and divide by 2, 8 divided by 2 is 4. Now, this time, there's no variable on the top. The only thing that we have is on the bottom. The larger thing is on the bottom, so that's where we're going to leave it. The x squared stays on the bottom, and here is our answer. Now, each time that we tried to divide anything on the top by one term on the bottom, what we did was to take each term on top and individually divide it by the term that is on the bottom, just reducing a bunch of fractions over and over. No matter what you've got on top, if you are dividing by one term, take each thing on top individually dividing by that term on the bottom and reduce those fractions, remembering our exponent rules.